Hey, the nth term divergence test. You're going to use this test or many other tests when you look at a series and you say, hey, that doesn't look like it belongs to one of the three famous families. If it doesn't involve one of the three famous families, then you've got to choose a test, or you could choose multiple tests out of this big long list that we're going to learn. So, some terminology before we move forward. A reminder, when you have a series like this, if you want to think about it in symbolism notation, this part right here is a sub n, and as I plug in different n values, I get a first term, a second term, and a third term, and so on. So keep that in mind as we look at this rule. And now I will unveil this rule. It's pretty straightforward. It simply says this. Let's take the limit as n approaches infinity of that equation that was in the series, and if it's not 0, then I have a divergent series. It's that simple. You shouldn't add anything else to it. And one thing to point out, it's the nth term divergence test, so we conclude divergence if this turns out to be true. We cannot conclude convergence. You just can't do it from the nth term divergence test, but your brain is going to try to tempt you and lead you down that path. In fact, there's that warning in writing. This rule says nothing about convergence, so beware, because I know you're going to be tempted. Before we go on to some examples and some intuition, some really good advice is this should be probably the very first test you try whenever you come across a series and it doesn't fit into one of the families. All right, so what is this saying? It's saying that if a series is divergent, then those individual terms must not be heading towards 0. In other words, if the limit as I head towards infinity of all these terms is not 0, it means these terms aren't getting small enough to cause the series to be convergent. In fact, if they're not getting small enough, then the series must be divergent. And I've tried to sum up that intuition here in blue using unofficial math language. You should pause the video a moment and read that and digest it. So another way I could state that is, this is telling me that the terms in the sequence are not getting small enough. All right, well, let's move on and look at it in an example or two. I look at this series and I say, hey, it's probably not a famous family of series. I could maybe try some algebra trickery, eyeball adjustments, and see if I could turn it into one of those, but I'm not going to bother because the nth term divergence test is my friend. And what I'll do is I'll try the nth term divergence test first, and I'll write that out. Good thing I'm good at limits from my previous calculus career. And as n approaches infinity, my numerator becomes much more powerful than my denominator. It's the battle of the big dogs happening right there. Well, that means that this is headed towards infinity. I really don't care if it's headed towards infinity or the number 17 or the number pi. As long as it's not headed towards 0, that's all I care about. Well, that limit is definitely not headed towards 0. So then I write my conclusion. This is a divergent series by the nth term divergence test. This is a classy move for the AP. Name that it's divergent, and then name the test why you believe it to be divergent. Let's do one more example. For a bit of foreshadowing, I wrote this example in red. Red meaning evil. So this doesn't look like it's one of the major families of series. So then I say, okay, well, I'll do my limit. As n approaches infinity, n squared becomes much more powerful than 5n, which means these terms close in on 0. You know what you're tempted to say here? You're tempted to say convergent, but you're not allowed to say convergent because you're using the nth term divergence test and it only can conclude divergence. So what you'll say is there's no conclusion, and then you'll go ahead and try to find another test that works. Just because the terms are headed towards 0 doesn't mean it's convergent. But if the terms are not headed toward zero, it does mean it's divergent. It's a lawyer-like distinction there. And it turns out I played a little trick on you guys. You might have figured this out. This is really the harmonic series in disguise. So if you do a little eyeball adjustment, you get 5 over n. That means you have n to the first power in the denominator, which is the clue for the harmonic series. You could take that 5 and put it out in front. You could leave it up on top, or you could say 5 times 1 over n. But somehow or another, you notice that's the harmonic series, and you know that the harmonic series is divergent. So you could have answered divergence by the harmonic series, but you certainly couldn't answer divergence by the nth term divergence test. So when you say, I'll try other tests, maybe your other test would be an eyeball adjustment to turn it into the harmonic series. In these examples, I've used very, very elementary limit problems. The limit problems can get spicier. The AP says they're okay asking you spicy limits. But in the end, don't let your mind do any more on the nth term divergence test than that simple statement.